In the past 2 years, the most important astronomical event has come. The first black hole photo in human history has finally been released. Event Horizon Telescope, the world's top astronomical observation project, released the first direct black hole image in the history of astronomy in the National Press Club of the United States.
Although it doesn't look so cool, this is a real photo, and reality is often the most powerful. The protagonist of the photo, the black hole in the center of the M87 galaxy, 6.5 billion times the mass of the Sun, 53.5 million light-years away from us. In contrast, the black hole Sagittarius A in the center of our galaxy is only 4.3 million times the mass of the Sun and is 26,000 light-years away. Before this, all the black hole photos and images we have seen were all rendered artistically, including those by NASA and ESO. A series of questions are coming. How was the first black hole photo born? The Event Horizon Telescope project, funded by the National Science Foundation of the United States, recently produced an official science video. The explanation is simple and easy to understand, clear. What is a black hole? How did it form? To put it simply, the end of massive stars has come, and they continue to collapse and evolve into dense celestial bodies that are so dense that they can infinitely bend time and space, and even light cannot escape. How dark is a black hole? Nothing can escape its claws, let alone spaceships, stars, and stars, not even visible light or invisible X-rays. Therefore, studying this kind of cosmic monster is much more difficult than climbing into the sky. The space of a black hole can be kneaded into an infinitely small point like paper, and time can be blown out like a flame. Will a black hole consume everything? Of course not. From a long distance, the total gravity of a black hole is actually the same as other celestial bodies of the same mass. For example, if the divine power is used, the Sun is now collapsed into a black hole, with a radius of 3 kilometers. The Earth and other major planets will still circulate in the original orbit, and will not be swallowed. The reason why a black hole can swallow everything around it is not because of its huge total gravity, but because of its super high gravity density. In other words, as a cosmic glutton, black holes still have a certain sphere of influence. This sphere of influence with no return is called the event horizon of the black hole, or the horizon for short. What is the horizon? What is event horizon? What is the event horizon of a black hole? The horizon is the horizon. When the night falls and the Sun falls below the horizon, even though we all know that the Sun still exists, it's just that we can't see it. The so-called event horizon refers to the events that are hidden under the horizon with the horizon as the boundary. We cannot see, reach, or know if we can. The event horizon of the black hole is like the black cloak of a magician, enveloping the infinitely collapsing black hole, and outside observers can't get a glimpse of it. How big is the black hole horizon? There is a proper term in physics, Schwarzschild metric. Named after German physicist and astronomer Schwarzschild, you can simply imagine it as taking a singularity point inside the black hole with infinite gravity and density as the center, and the gravitational radius, Schwarzschild radius, calculated by Schwarzschild himself, delimiting the sphere of influence of a black hole. The simplest it is spherical, complex pumpkin-shaped, donut-shaped. Remember, as long as you break into the black hole horizon defined by Schwarzschild's radius, you and I have no choice but to run. What is the Schwarzschild radius? Take the Sun, its Schwarzschild radius is about 3 kilometers. If all the mass of the Sun is compressed to within a radius of 2.95 kilometers, our Sun will become a black hole. The Schwarzschild radius of the Earth is only 9 millimeters. This is equivalent to pressing the Earth into a raisin to become a black hole. You just have to remember, only the swallowing range of the black hole, the Schwarzschild radius, is the meat bun hitting the dog, and there is no return. What if you hide in a place farther than Schwarzschild's radius and become a melon eater? How many black holes are there? There are far more black holes than we thought. When it comes to black holes, they are often billions of light years away, as if they are far away from our Earth. In fact, in our Milky Way galaxy, there are about 100 million black holes. Of course, they are basically small-mass black holes 330 times the mass of the Sun. Although this data is calculated by astronomers rather than actual observations, it is an inevitable result according to the prediction of the stellar evolution model. Astronomers estimate that the black hole closest to the Earth is likely to be 300 light-years away in the deep space of the universe. Who foresaw the black hole first? In the late 18th century, both British Michel and French Laplace foreseen that there must be dark stars in the universe that even light cannot escape. Who named the black hole? John Wheeler, America's top physicist. The scientific community gave him a high evaluation. Wheeler is the last giant, the last superhero of physics. He is also the originator of wormhole, multiverse, quantum foam, black hole Sandmouth theorem, these widely circulated physical terms. The last superhero of physics. What are the black holes? In terms of quality, black holes can be divided into supermassive black holes. The mass is at least several million times the mass of the Sun. Intermediate mass black holes. The mass is more than tens of times the mass of the Sun, but far smaller than supermassive black holes. Small mass black holes, also called constant star black holes, lighter-weight black holes, have a minimum mass ranging from 3.8 times the mass of the Sun to several times the mass of the Sun. Mini black holes, also called mini black holes, quantum black holes, are important objects for studying quantum mechanical effects on a microscopic scale. How big is the largest known black hole? Astronomers know the two largest gluttonous feasts in the universe. Ton 6 1866 billion solar masses, located in the constellation Canis. S50014 plus 8140 billion solar masses, located in the constellation Cepheus. But rest assured, we are far enough away, hundreds of millions of light-years away. What about the fastest growing black hole? The astronomical number of this cosmic monster, QSOSMSS J215728.2136021.5.1, referred to as J21573602. Please rest assured that it is far enough from us, 12 billion light-years away. This cosmic monster has existed as early as 800 million years after the Big Bang. Calculate that when the two singularities are close enough, you can pass safely. Is it possible? The question is related to wormholes. Is it possible that there is a space-time in which not only can you pass through the throat that looks like a black hole, but you can also pass through it safely? Wormholes, or shortcuts through time and space, were originally thought to be solutions to some equations of Einstein's general theory of relativity. Unfortunately, the first solution is like this: if you try to pass one of them, it will immediately crash and crush you, that is, your presence will prevent the wormhole solution from working. In the mid-1980s, because Carl Sagan wrote a novel, Contact, maybe you have seen this movie, he needed a wormhole where he could travel safely. They have found solutions to some equations, which allow the wormhole to be safely passed through. The only problem is that they must be composed of so-called foreign matter, whose total energy is negative. This is not as absurd as it sounds, but it is not completely impossible. By the way, one of the trickies of wormholes is that at any time, as long as your speed seems faster than light, you can go back in time. This is a corollary of Einstein's theory of relativity. So if you have a wormhole, you can travel through time and space. This can lead to many paradoxes. One of the most common is called the grandfather paradox. In this paradox, we assume that I am an outstanding scientist, but a real scumbag. I invented a time machine, and I used it to go back in time and kill my grandfather before he met my grandmother. Because he is dead, he cannot give birth to my father, and there will be no existence of me, which means that I cannot build a time machine to kill my grandfather, because I can meet my grandmother and give birth to my father, and me, so I can let the time machine kill him, so ... Paradoxes like this make some people believe that you can't travel in time, so your speed cannot exceed the speed of light, but it doesn't not as clear as it looks. I have heard people say that when interstellar matter reaches or touches the horizon of a black hole, it emits light and radiation. What does this mean? Why does this happen? Besides, if nothing but light can move at the speed of light, how can a black hole draw light into itself? It sounds like you might be confused about some things about black holes. They don't actually spray radiation, because nothing can escape from the black hole, in a reasonable time anyway. The stuffed material usually forms an accretion disk around the horizon, like water spiraling down a drain. When this substance rotates around the disk and approaches the black hole, it loses energy and radiates this lost energy. As someone approaches the horizon, the amount of radiation will increase sharply, because this is the steepest region of the black hole's gravitational potential, so the matter falls faster and therefore more energy is lost. You are right, because of the special relativistic effect, no mass object can move at the speed of light or exceed the speed of light. However, if the black hole enters the event horizon, it can still inhale light. By definition, the horizon is the distance from the central singularity. For a black hole of a given mass, its escape velocity must be equal to the speed of light. Therefore, at that distance, the object must move faster than c in order to escape the black hole's gravity. This is impossible, because light moves at the maximum speed of c, so even light at such a short distance will be pulled in. The escape velocity of a black hole is sqrt2 where g is the Newtonian gravitational constant and m is the mass of the black hole. Therefore, as the mass of the black hole increases, the speed required for the escape of the object also increases. What is the difference between black holes and white holes? Before discussing white holes, we need to consider black holes. How do we know the existence of a black hole? There are two ways to prove it. First, we have conclusive evidence from the telescope. Telescopes have been used to observe the light emitted by objects in orbit. We cannot see with telescopes. These dark and heavy objects appear to be very small compared to the objects of similar or greater mass that we can see. These black and large objects are likely to be black holes. Secondly, we have an excellent theory of gravity, which has been carefully tested and predicted that we will definitely see such an object in the universe. So where did the white hole come from? Our theory of gravity, Einstein's general theory of relativity, predicts that a black hole is a solution to a set of equations. The solution of Einstein's equation can be preceded by a plus, positive, or negative sign. We often see this in mathematics. The solution of y equals 9 can be y equals +3 or y equals 3. Depending on the symbol you choose in Einstein's equation, you will get a black hole that grows by absorbing distant material, or you will get the opposite result, a white hole. It is a black hole going backwards in time. What would a white hole look like? Well, if you have a camera recording the process of a black hole absorbing matter, and then play it back, you will see a white hole. You will see the material being spit out by the white hole. When it spit out the material, the size of the hole will gradually decrease. But is white hole real? Just because an equation describing the world has a negative solution and a positive solution does not mean that it is a correct description of things. If I tell you that the square of my baseball votes is 9, it means I have 3 votes or lose 3. But losing 3 baseball tickets is meaningless. There is no such situation. There are many examples of equations in dynamics. There are positive and negative solutions in time, but only one can describe the real world. This is because we can see time moving in one direction as long as we look around. The time never seems to be reversed, and will not replay for an hour or a day. Therefore, we believe that the white hole solution of Einstein's equation is one of the solutions that are not suitable for the real world. It's like losing 3 tickets to the floor. This will not happen at all. The last point is observation, because you can get all the beautiful equations you want, but they must be consistent with what we see, otherwise they are useless. The current observations tell us that we are right, and we have seen a lot of great evidence about black holes. But so far, none of them are about white holes. I know that black holes have a large gravitational field. If they pass through the black hole, everything will disappear. What happens if the sun passes through a black hole? The sun also has a large gravitational field. Will the sun disappear? If the sun passes through a black hole, it will disappear in the black hole like anything else. When anything, light, spacecraft, or even the sun, is too close to a black hole, the gravitational pull of the black hole is so strong that the object cannot escape, even if it moves at the speed of light. The distance between a black hole and a black hole is called the horizon. A black hole, there is nothing inside to escape. If you drive a spacecraft close to a black hole, as long as you fly out of the horizon, you can safely orbit around the black hole. However, if you go too close and pass the horizon, there is no way to escape. Similarly, if the sun is so close to the black hole that it is within the horizon, it will not be able to escape and will disappear. If we can control a singularity, its location, size, and/or destination, what do you think we will use it for? First, remember that most people believe that there is a form of cosmic censorship, which means that one cannot have a naked singularity. This means that there will be an event horizon around a true singularity in the universe, so, 1, you cannot see the singularity directly, and, 2, in fact this is a black hole. Therefore, if one can control a black hole, then a constructive use will be to generate a lot of energy. Gas spirals into a black hole from a long distance, and usually releases about 10% of its mass energy before finally falling into the black hole's horizon. The reason is that the gas is forced to move at a very fast speed, so it will rub against itself and heat up, thus generating radiation. This is about 10 to 20 times the energy released by nuclear fusion, which is suitable for any substance. In other words, you can imagine throwing garbage, perhaps toxic waste, into a black hole and then using the energy generated in this way to power human civilization. 1. A black hole refers to an ultra-high-density celestial body in the universe. It is a black body that does not reflect light at all, so it is called a black hole. Black holes are produced by the gravitational collapse of some stars larger than the Sun after their nuclear fusion reaction fuel is exhausted and death, which can generate a strong magnetic field. 2. Black holes are mostly places where stars in the universe die. If you want to compare them, black holes are both a cemetery and a garbage recycling station. So what is inside a black hole, in simple terms, is the remaining energy of the universe or the celestial body swallowed by the black hole, such as compressed light, squeezed planet. 3. Black holes occupy 90% of the total mass of the universe. Black holes can be said to be everywhere. In a more specific analysis, we can find some evidence from the formation of black holes to explore what the black holes of the universe contain. 4. The production process of black holes is similar to the production process of neutron stars. The core of the star shrinks rapidly under the action of its own weight, and a powerful explosion occurs. When all the matter in the core becomes neutrons, the contraction process stops immediately and is compressed into a dense planet. 5. But in the case of a black hole, because the mass of the stellar core is so large that the contraction process continues endlessly, the neutron itself is crushed into powder under the attraction of the squeezing gravity itself, and what is left is a density that is unimaginable of the substance. Anything close to it will be sucked in by it, and the black hole becomes like a vacuum cleaner. A black hole is a kind of celestial body in the universe in modern general relativity. The gravitational force of a black hole is so great that the escape velocity in the horizon is greater than the speed of light. In 1916, German astronomer Karl Schwarzschild obtained a vacuum solution of Einstein's gravitational field equation through calculations. This solution showed that if a large amount of matter is concentrated in a single point in space, strange phenomena will occur around it. That is, there is an interface around the mass point. Once the horizon enters this interface, even light cannot escape. This incredible celestial body was named black hole by American physicist John Archibald Wheeler. A black hole is a celestial body whose space-time curvature is so great that light cannot escape from its event horizon. A black hole cannot be directly observed, but it can be known about its existence and quality through indirect means, and its influence on other things can be observed. The information about the existence of the black hole can be obtained by the edge information of the gamma rays and the high heat emitted by the object before it is sucked in. It is speculated that the existence of black holes can also be used to obtain the position and mass of stars or interstellar cloud gas clusters by indirect observation. On December 7, 2017, scientists from the Carnegie Institute of Science in the United States discovered the most distant supermassive black hole in history. Its mass is 800 million times that of the Sun. Since humans began to explore the universe, we have learned more and more about the universe, but we feel that we are getting smaller and smaller and the universe is too big. Humans may never reach the edge of the universe, even the Milky Way. So what is worth exploring inside the Milky Way? That is the black hole in the center of the Milky Way. For a long time, the most mysterious star in the universe has been a black hole. Even light can't escape. Anything close to it will be sucked in without a trace. And all the stars in the Milky Way will be sucked in by the black hole in the final outcome. Scientists have always been worried that a black hole has such a big appetite. Can it be filled with dissatisfaction? So what is in the black hole? Maybe we will never know the answer. Even if someone goes in and sees what's inside, they won't be able to get out. They can't tell us what's inside the black hole. Some people say that there is another universe inside the black hole, which is what we call parallel. The universe, because only another universe can have enough space to accommodate the sucked planet. The concept of black holes also originated from a story more than 100 years ago, that is, the great Einstein put forward the general theory of relativity. I won't talk about the specific description of general relativity, because no one can understand it now. But it is precisely when solving the general relativity equation that a solution of a point mass, no rotation and no electric gravitational field is obtained. The nature of this solution has a horizon where time stops and the redshift is infinite. Another feature of this solution is that everything, including light, can only go in but not come out. Scientists think this solution is very incredible, and has a very vivid name, the black hole solution. The center of the Milky Way that was later explored satisfies this solution. Therefore, science and technology believe that the center of the Milky Way is probably a black hole. With the invention of astronomical telescopes and radio telescopes, we have found many such black holes in the depths of the universe. But we can only look at the black hole from a distance, but we can never get close, so we may never know what is in the black hole. We really don't know much about the nature of black holes, but the reason why humans are called intelligent creatures is because humans have created civilization. We have thoughts and we can't see what's in the black hole, but we can imagine what's in it. Doesn't the development of mankind depend on imagination and then turn dreams into reality? A black hole can capture even light, so in terms of ability, the rotation speed of a black hole is higher than the speed of light. At present, the only thing we know that can exceed the speed of light is the expansion speed of the universe. That is to say, the speed of the expansion of the universe and the speed of the black hole are also higher than the speed of light. Then, between the black hole and the expansion of the universe, one is to absorb infinitely large things and become smaller, and the other is to infinitely grow. So what is the relationship between the two? Scientists don't know it yet, but it is conceivable that black holes are an alternative existence in the universe, and there is also a certain connection between black holes and the universe. It is very likely that in hundreds of millions of years, the super-large black hole in our universe will be able to absorb all the stars in the entire universe. Then our entire universe may become a black hole. Having said that, there is another contradiction. What we know is that the universe is expanding and getting bigger, and it is formed by a singularity explosion. If the entire universe is absorbed by black holes, it will become infinitely smaller and become a singularity. So, does our universe change from a singularity to infinity, or from infinity to a singularity? This is exactly what the editor suspects. If these two situations happen at the same time, then it seems to violate a certain scientific thesis. Perhaps the universe can only be explained clearly by philosophy. Black holes can only be detected after we fully understand the universe. When the time comes, what is in the black hole, we can go in and take a look. Perhaps in the black hole, we can really find another universe. In short, the existence of black holes does bring a lot of mystery to the universe. What is inside the black hole? Scientists are also constantly exploring, hoping that one day in the future, mankind will be able to answer these mysteries. In the universe, human beings may belong to advanced civilizations. Perhaps only the advanced civilizations of the universe can shuttle back and forth between black holes without worrying about getting in and getting out. There is a legend that entering a black hole can travel through time and space. Although this argument is too science fiction, we really have no evidence to prove that this is false. Is it our past in the black hole? Or the future? These questions are waiting for scientists to answer.